Open Proteus app and select new project. Name your project and choose the save location and click next. Click next. Click next. For component selection, go to the Pick Devices menu to select components. Then in the dialog box, search for components like resistor, capacitor, transistors, etc. whichever needed. Select and add components to the project workspace by double click on them.
To place the components, drag and drop components from the library onto the workspace. Now I will explain component specifications. LDR, a light depend resistor whose resistance decreases as light intensity increases. Resistors R1 and R2 from a voltage divider to set a reference voltage. R3 limits the current to the LED. Op-amp, the OP27G operational amplifier acts as a comparator. LED D1, the LED lights up depending on the output of the op-amp. Battery provides a 9-volt supply to the circuit.
Working of the circuit, the op-amp is configured as a comparator. The non-inverting input of the op-amp receives the voltage from the LDR, while the inverting input is connected to a reference voltage and created by the voltage divider R1 and R2. When the light level is low, the LDR's resistance is high, causing a higher voltage at the non-inverting input. If this voltage is higher than the reference voltage at the inverting input, the op-amp outputs a high signal. The high output from the op-amp drives current through the LED D1 and resistor R3, lighting up the LED. As light intensity increases, the LDR's resistance decreases, reducing the voltage at the non-inverting input. When this voltage falls below the reference voltage, the op-amp output goes low, turning off the LED.
Now steps for designing the circuit. Step 1. Understand the circuit purpose. This circuit uses an LDR to control the LED based on ambient light levels. When it's dark, the LED should turn on, and when there's light, it should remain off. Select the components. LDR detects light, its resistance decreases as the light level increases. Resistor R1 10k ohm forms a voltage divider with the LDR to create a reference voltage at the non-inverting input of the op-amp. R2 10 ohms connected to the inverting input to help set the trigger threshold. R3 current limiting resistor for the LED op-amp. The op-amp 27